We're going to do kind of an overarching, like how to help you with some homework problems for those of you who are kind of stuck. I'm just going to kind of glob a few together and give you some ways to kind of get out of this process without making it. I want to get to the concept of things, and I think the algebra has held up a few of you. So let's just get down to the nitty gritty. So I have a problem that I've looked at. One of them is x squared minus, this is number 4, x squared minus 9 over 5x plus 4. If you haven't figured out, there are ways to manage this, x squared minus 9 over 5x plus 4. And the question is, if I take a look at it, to concave up or concave down, determine that kind of thing. So if I were to go do this, the first thing I'd do is I'd grab my calculator, or my computer calculator, and I'd say, all right, let's graph this thing. The reason I put this on here is I found some other problems that were similar. I've been dealing with them, and I thought, there's a theme here. I can probably help you guys out. Let me give you some tools to get you over the hump. All right, here's 8x squared minus 9 over 5x plus 4. You graph it. Concave up is something you should just recognize. If you look at this graph here, concave up is anything that's kind of a cup facing up or any portion of a cup facing up. This whole left is concave up. The whole right is concave down because it's a cup shaping down. So you at least need to have the conceptual sense that if you look at this, and I pick a different color here, let's go blue. There's a side that looks like this and a side that kind of looks concave down. The right hand side in purple here is concave up, and the left hand side here in orange is concave down. Oh, you can't see what I'm doing, sorry. I got that off the screen. So I got it highlighted. So concave up in purple and concave down there in orange. The issue is how do I write the interval? Because that's asking for interval notation for the, from negative infinity until I hit whatever this vertical asymptote is. It seems to be concave up, and then there's this vertical asymptote from whatever that number is to infinity that it's concave down. So we label those, concave up, and this would be concave down. I need that number. So we're really interested in what is in that spot there. So we're going to go for the pink, right? Hunting for the pink. That's where the derivatives kick in, and they get really gross looking in some cases. And there's a couple ways we could do it. We could do it by quotient rule. We don't need so if this is f, we don't need f prime is for peaks and valleys. I don't want that. I want concavity, which is f double prime. So even getting the first derivative, it's pretty hefty. I mean, got to do quotient rule low is the bottom, d high, you get 2x, s high, d low, and you get x squared minus 9 for your high, and then d low is just 5. Looks okay to begin with. Over the square of low we go. Okay, then it's fine. If we were looking for peaks and valleys, we'd set the numerator equal to 0, the denominator equal to 0, and see which ones represent. Remember, numerator equal to 0 means where the derivative is 0. Denominator 0 is when we're talking about being undefined. That's pretty easy, but the second derivative is a big kind of hairy mess, because even after simplifying this first derivative, it's a hard second derivative. So to save you some time, and we're at a late stage in this process, I recommend, if you haven't found these already, is go to some tools. So if you've never done Wolfram Alpha, it's a fine program, and I have already in here second derivative of, you see in my sentence. Well, that's going to do it for you. I'm going to change mine. I had one before for, excuse me, another student. We were doing x squared minus 9. Oops, look, I'm in the wrong place. X squared minus 9 over 5x plus 4 is the problem I'm dealing with now. So if we do over 5x plus 4, you want to be careful to use parentheses for numerator and denominator and a division symbol. So notice how I typed it. How you enter it is very important. Cool thing is down below it will show you what you typed in a nicer form, so you can pretty much pick up on whether you goofed it up or not. So when I hit enter here, let's look at it saying, it's got this fun notation d squared over dx squared. That means second derivative of, and it says x squared of minus 9 over 5x plus 4. Hey, that's my problem. And next to it, there's the result. Capitalize on that. If you're stuck, your second derivative work shouldn't take you 2 hours. So I want you to go ahead and say, all right, negative 418 over 5x plus 4 to the third. I'm going to go with that. So f double prime is negative 418, right? Is that what we found out? Let me scoot this over so I can see 2 at a time. Scoochy scooch. And negative 418 over 5x plus 4. Got it. I can handle that to the third. And the deal is to deal with concave up and concave down, that break point where it changes is where I set the second derivative either equal to 0 or find where it's undefined. Setting it equal to 0 is looking at where, you've got 0 on top. The numerator being 0 would make the whole thing 0. Well, that's not going to happen. It's negative 418. So The other option is when is it undefined, and that's when the denominator is equal to 0. That has potential. If that 5x plus 4 ever equals 0, then we'll be undefined, and we have what is a possible change of concavity, because we're looking at the second derivative. If I subtract 4 and divide by 5, I get negative 4/5. That negative 4/5 is that miraculous place in the graph I just put up there, where if I graph it, x equals negative 4/5, it's the line where it bets up against. That's where my intervals stop and start. So when I go do my answer, you want to use both of these tools to your advantage. It's concave up from negative infinity to, sorry for all my alarms going off here, I'm getting all kinds of information, negative 4/5. Here we go. And then it's concave down from negative 4/5 to infinity, and that will answer number 4 on your particular problem. Okay, let's move forward. I'm going to go to number 7 now. So we'll group 2 together and get efficient about this if you're interested in 7. If not, then move on. So here's 7. It says find all the relative extrema. Use the second derivative test when applicable. Because we're looking at the graph, it's not really applicable. I'm going to graph x over x squared plus 4, and I'm not really going to need much of the second derivative test. I'm going to go in here and go, all right, I'm going to graph you, what was the problem again? X over x squared plus 4. So it's x over x squared, there it is, plus 4. Looks like I got something here. I'm going to delete that little exponent there, get rid of this. Hey, that's nice. And that graph right there, it's kind of hard to tell, but Desmos has already pointed them out to me, so already I've got that much going for me. But you want to practice making sure you can use the calculus to provide this as well, because when a test or quiz comes along, you won't have Desmos to save you. You might have a graph nearby that's ambiguous, but this will work. So going back to our problem, x over x squared plus 4, give me relative max and min. And here's how I tackle this. And x over x squared plus 4, that's my y, and I want y prime is all I need for extrema. Now, that's different from the last problem, and that's why I'm grouping these two together, is to realize we look for max and mins with the first derivative, we look for concavity with the second derivative. So the type of question you have determines what derivative you need. This one is extrema, max and min, so I only need the first derivative, and so voila, I don't know what happened to my screen there. It is a quotient rule if you want. Some of you have found out there's other ways to do it, like a product rule and rewrite it, but I'm just going to stick with what I got. X squared is the low plus 4. D high would be 1 less high. D low, 2x. And over the square of low we go. X squared plus 4 quantity squared. Now simplifying that, or setting is helpful. I only need the first derivative, so I'm just going to do a little bit of work like x times 2x, and maybe combine some terms, so x squared plus 4 on the left minus 2x squared over the denominator, and then I'd probably go, hey, these guys are like terms. I'm going to rewrite them as x squared minus, that's negative x squared, and just get those off of there. Scrub, 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 scrub. And here we go, negative x squared over x squared plus 4 squared. That's my y prime. Your job is to set it equal to 0, which means when is the numerator 0? And when is it undefined, which means when is the denominator equal to 0? And that is a skill you should get as well. This denominator will never be 0, because you're squaring something, you're adding 4 to it, and then squaring it again. It's not going to be 0. It's going to be positive, and it's never going to, you can't put in anything to make that 0. Negative 2 is the usual culprit, but negative 2 squared is 4. So you add 4 to that, you get 8. So this will never be undefined, but the numerator will be 0 if I solve that little equation. So I will. Okay, negative x squared plus 4 equals 0. I add x squared to both sides, and I take the square root. X is plus or minus 2. Those are possible extrema. So, and if you remember back in our graph, of course, that's what we saw. Those are the two places. So you'd go in and say my relative minimum occurs at negative 2, and we don't have the coordinate, negative 0.25, and it happens at 2.25. Remember in class we were deciding we couldn't get it as precise as we wanted with Desmos. Remember what you can do is you can actually sub those values in. If I put 2 into my original function, you can find out what that actual point is without guessing. And so this is me putting 2 into the original function to find out that I'm going to get out. I already know what it is. It's 0.25. But here's the mathematics of finding that. 2 over 4 plus 4 is 2 over 8, which is 1/4. There you go. Ta-da, there's the 0.25. And you do the same thing on the other side for -2. That's the story on that. And I think, did we answer the question? That's always one. Relative minimum, you want a coordinate point. Error I saw in some of your homework is you added another set of parentheses. So you want to be careful. My maximum was on the right at 2 comma 0.25 or 1/4. So I might even put it in 1/4. You don't need to add parentheses to that. So you want to be extra careful that you just do 2 without parentheses, comma, because they're already provided right here. And sometimes we miss that. I certainly do when I'm looking at these. I don't see it all the time. And that would be correct on this one. I'll hit submit for testing. And voila, we get it all right. And life is good. Okay, so there's 7. That's that package of problems. I'll send you another one here in just a second. Hopefully I can turn this off okay.